Well, in the series of case studies, we have taken one more case study based on application of derivatives. Well, in most of the case studies you have seen that the picture given in the question is generally just a representative, symbolical. There is nothing, no data is given in the question generally, but here you can see that some data is given in the picture. So here that makes it important. See, the horizontal length, that is this length, is given as x meter and this height or width is given as y meter. So now we cannot interchange x and y, or we cannot take it as 2x, or we cannot take this as r or something else, some other variables, because if you will go and read the questions, what you will find is all the questions are in terms of x and y given in the drop. Let's read it out and then we'll solve. Rajendra visited a historical palace in Rajasthan. He observed that the window of the house is in the form of a rectangle surmounted by a semicircular opening having perimeter 10 meters. So we are given the perimeter of the window as 10 meter as shown in the figure. Based on above information, answer the following questions. Here the very first question is if x and y represents the length and breadth of the rectangular region, and it is very clearly shown that this part is to be taken x and this is to be taken as y. That's why the draw here is important. Now, what will be the relation between x and y? Alright, the second question is the area of window. The area of window will be the sum of area of rectangle and semicircle. The sum of area of rectangle and semicircle. Alright, the area of window. Then Rajendra is interested to maximizing the area of whole window. So whatever we have found in question 2, we are to maximize that, and that is in terms of x only. Then we will differentiate it with respect to x and we will equate it to 0 to get the value of x where the area is maximum. Alright, and what will be the maximum area of the window? Of course, maximum area of the window will put the value of x obtained in the formula or whatever the expression we have got for area, and we'll find the area. And the last question is for maximum value of area, the breadth of the rectangular part of window. Breadth, see, length is x and breadth is y. This is considered as length and this is considered as breadth. So we are to tell the breadth, that is y. See, it is very clear, x is the length and y is the breadth. So read the question carefully and answer the questions accordingly. Let's start. See, we are given the perimeter is equal to 10 meters. So here P is equal to 10. Okay, the perimeter, suppose I name it as A, this point is B, this corner point is C, this is D. Then the perimeter is the sum of the boundary, this boundary. Okay, so this is actually AB line segment, right, plus B to C, BC line segment, right, plus C to D. This is not a straight line but a semicircular arc. So CD arc plus D to A, this DA. This actually is given as 10 meter. Alright, AB simply is x meter, alright, plus BC is clearly y meter, right, plus CD, we know that this is the perimeter of semicircle, and we know that the circumference of a circle is 2 pi r. So half of circumference we need. Half of circumference is 2 pi. What is the radius of this window? See, this is the diameter, and diameter actually is equal to x meter. So half of diameter will be x by 2. The diameter is x, the parallel side of opposite sides of rectangle, because this is a rectangle, so this is x, so this will be half of x. So radius here is half of x, that is x by 2, plus DA line segment, D to A, this will also be equal to y because opposite sides of rectangle are equal. So this is y is equal to 10. See clearly, this is x plus y plus half of 2 pi x by 2 plus y must be equal to 10. So here we can see x plus y, and y will give me 2y plus half of 2 pi x. So this actually is pi by 2x or pi x by 2 is equal to 10. So this is the relation between x and y. So here we have got the relation between x and y. If x and y represents the length and breadth of the rectangle region, what will be the relation? The right hand side here is 10. So here also in all the question 10 we have x plus 2y plus pi by 2x. X plus 2y plus pi by 2x. Yes, this is the correct answer. Area in terms of x only. Now if we want to find the area in terms of x only, so we will find y from here. Y is equal to 2y is equal to simply 10 minus x minus pi by 2x. So if I divide both the sides by 2, I'll get 5 minus x by 2 minus pi by 4x. This is the value of y. Now we want to find the area. Area of window. Area of window is equal to area of rectangle plus area of semicircle. Area of rectangle is length into breadth, that is x is the length and breadth y is the breadth. Area of semicircle, that is half of area of circle, half of pi r square. R here actually radius of the semicircle is x by 2 as discussed above. Obviously the radius here is x by 2. So now we want the answer in terms of x only, so we'll replace y with this expression. Alright, this is actually 5 minus x by 2 minus pi by 4 times of x plus half of pi into x square by 4. Alright, this gives us 5x minus x square by 2 minus this x bracket, on opening the bracket, 5x minus x square by 2 minus pi by 4 x square plus this will give us pi by 8x square. Alright, on solving this is 5x, alright, minus x square by 2 minus pi by 4 and plus pi by 8, that will give us minus pi by 8 x square. So this is the area in terms of x. Let's see which option is correct. 5x minus x square by 2 minus pi by 8x square. 5x minus x square by 2, this is plus, this is plus, this is minus, but here it is x cube. So this is the correct answer, B part. Alright, now the next part is Rajendra is interested to maximize the area. To maximize the area, dA by dx must be 0. So now we find the derivative of a with respect to x. On differentiating it with respect to x, let's see what we get. On differentiating with respect to x, 5 into the derivative of x is 1 minus the derivative of x square is 2x upon 2, that will give me x, and the derivative of x square is 2x, that is pi by 8 into 2x. So this actually is, on equating this to 0, what we get is 5 minus x minus pi by 4x is equal to 0. We want to find the value of x, so we transpose all the terms containing x. X plus pi by 4x is equal to 5. On taking x common, this is 1 plus pi by 4 is equal to 5. And on solving, what we get on taking 4 LCM to x, 4 is the LCM, that will give us 4 plus pi is equal to 5. So obviously the value of x is 5 4s are 20 upon 4 plus pi is the value of x for which the first derivative dA by dx is 0, that is for maximum. So this is our answer, 20 upon 4 plus pi. 20, what will be the value of x for maximum area? 20 upon 4 plus pi. 20 upon 4 plus pi. The C is the correct answer. Now the next question is question 4, maximum area of the window. So maximum area of the window is 5x minus x square by 2 minus pi by 8x square. So this area actually is area, just a second. Area is equal to 5x minus x square by 2 minus pi by 8x square, minus x square by 2 minus pi by 8x square. Okay, we can take x common, so this will give me 5 minus x by 2 minus pi by 8 times of x, and the value of x for which the area is maximum is here 20 upon 4 plus 5. So we put the value here. So area is x. X is actually 20 upon, just 20, the value of x is 20 upon 4 plus pi. 20 upon 4 plus pi multiplied by 5 minus, if 20 is divided by 2, this will give 10 upon 4 plus pi. 5 minus 10 upon 4 plus pi minus pi by 8 times of x. Pi by 8 times of x, x actually is 20 upon 4 plus pi. So this 5 4s are 20 and 4 2s are 8. So 20 upon 4 plus pi. If we try to take LCM, the LCM is 2 times of 4 plus pi. 2 times of 4 plus pi. So this 5 will be multiplied by 2 times of 4 plus pi. That will give me 10 times of 4 plus pi minus, the LCM is 2 times of 4 plus pi. 10 2s are 20 minus this 2 times of 4 plus pi is LCM. This is actually 5 pi. Alright, let's solve it. Let's see what we get. This is 20 upon 4 plus pi upon 2 times of 4 plus pi. Now the numerator becomes 40 plus 10 pi minus 20 minus 5 times of pi. So 20 upon 4 plus pi multiplied by, this actually is 2 times of 4 plus pi. This is 40 minus 20 is 20 plus 10 pi minus 5 pi is plus 5 pi. So clearly 5 is common. 5 can be taken common from here. This is 20 times of 4 plus pi. If I take 5 common from numerator, that is actually 4 plus pi, which can be cancelled out. So this is our final answer. 4 plus pi will be cancelled out. This 2 10s are 20. So 10 into 5, the numerator is 50 upon 4 plus 5. This is the area of the maximum area of the window, 50 upon 4 plus pi. 50 upon 4 plus pi. This D is the answer. See here, this question demands calculation. You can skip this question because we are to attempt any 4. Attempt any 4. So you can go for this one. This is easy. For maximum value of A, the breadth actually is y. In the first question, it is very clearly mentioned that y is the breadth. So the breadth of the window and the relation between x and y is here. This is the relation between x and y. So you can find the breadth, that is 5 minus x by 2 minus pi by 4x. 5 minus x, 5 minus the breadth is y is equal to 5 minus x by 2 minus pi by 4x. Minus pi by 4x. Pi by 4x. You can put the value of x here and find the value of y. 5 minus half of this x. This x is 20 upon 4 plus pi. So half is 10 upon 4 plus pi. 10 upon 4 plus pi minus pi by 4 into x. If I cancel this 4 with 20, I will get 5. So 5 pi upon 4 plus pi, and you will get the answer immediately. That is, you take the LCM 4 plus pi. This will give you 5 4 are 20 plus 5 pi. 20 plus 5 pi minus 10 minus 5 pi. 5 pi will be cancelled out. 20 minus 10 is 10. 20 minus 10 is 10 upon 4 plus pi. 10 upon 4 plus pi is the answer. This will be the easier part. So this question demands calculation. You must have seen this is a most frequently asked question in the Cbse board exam. Now this is converted to the case study. So what we take care of, whatever the data given in the question, in the picture, that must not be changed while solving. If this is given x, then we are to treat it as x, and if it is given as r or 2r, then or 2x, then we are to treat it accordingly. That will change all the calculations. Thank you so much for joining. We'll be again discussing some case study in the next session. Thank you.